Hello everyone, this is S. Bhargav, working as an assistant professor in the Department of EI, VNR VJIT, Hyderabad. Today I am going to discuss a topic called representation of signed number from the subject switching theory and logic design. Any binary number, as we know, it is represented either in ones or zeros, right? So binary number means we will have either 1 or 0. So while representing any positive number is not a problem. For example, what is 101? 101 means 5. So, but in practical life or real life application, 5 can be either -5 or +5, right? So for representing a binary number in negative form, or you can say as in a sign magnitude form. Sign magnitude means it can be either a positive number or a negative number. So it can be a -5 or +5. So it becomes a challenging task how we can represent, because in real life we have a sign called plus and minus, but in digital electronics we have only ones and zeros, right? So now we will discuss how we can represent a signed number in binary form. So for representation of any signed number, there are two methods. First one is called sign magnitude form. Second one is the complement form, right? So what happens in a sign magnitude form? In sign magnitude form, we will use one extra bit, or you can say we will use one additional bit, which is called a sign bit, and it is generally placed in front of the number. It is placed in front of the number, right? So in sign magnitude form, we will use one extra bit or additional bit, which is called a sign bit, and it is placed in front of the number. Now, if the sign bit is 0, then it indicates that the number is positive. If the sign bit is 1, it indicates that the number is negative, right? So what we understood is we will use one extra bit, which is called a sign bit, and if the sign bit is 0, then the number is positive, and if the sign bit is 1, then the number is negative. So let us take a simple example. 101. What is 101? We know 101 indicates 5. So now to represent +5, how I am going to represent? I will place a 0 in front of 101, right? So what is this 0? This 0 is called as the sign bit. This 101 are called as the magnitude. So sign S0. When sign bit is 0, the number is positive. So it indicates that the number is +5. Now second example. I want to represent -5. So 101, in front I will place a 1. So this 1 is my sign. This is my magnitude. As my sign is 1, 1 indicates negative. So it is called as a -5. Clear? So let us take one more example. I want to represent 15. So 15 is 1, 1, 1, 1. I want to represent +15. So +15 will be 0, 1, 1, 1, 1. And I want to represent -15. So -15 will be 1, 1, 1, 1. Clear? So this is my -15 and this one is my +15. So this is how we can represent any given number in sign magnitude form. Clear? So we can represent in positive version as well as a negative. Now there is a disadvantage of the sign magnitude form. So let us assume that there is a 3-bit number. So whenever there is a 3-bit number, we are having 8 combination from 000 to 111. So there is a combination of 100, which is in a sign magnitude form. Let us assume 100 is a number which is represented in a sign magnitude. So first of all, looking at the number, what is the idea which you got? This first one, what does it represent? Sign. This next 2 bits, it represents the magnitude. So what is the sign of this number? The sign of this number 1 means negative, 00 means 0. So 100 means -0. But -0 is practically not at all possible, right? -0 is practically not at all possible. So the same problem will continue. 100. If you further take 1000, again it is also -0, right? So -0 is practically not possible in any number system. So that is the main reason that sign magnitude form, is not preferred. That is the main reason that the sign magnitude form is not preferred, or it is not at all used. So as I said, that this is the main problem. So to overcome this problem, the next method, that is called the complement method, was designed. So next we will discuss about the complement method of representation of any given signed number. Now we are going to discuss our second method, that is called the complement form. So before discussing about the complement method, I hope you know how to find out the complement of any binary number. If you don't know, you can just check my previous videos. So we will have a quick recap what is complement. So for example, there is a number 1 0 1 0. So this is a number. So the complement of this number is we have to interchange the bit 0 with 1 and 1 with 0. So what will be the complement of 1 0 1 0? It will be 1 0 1 0. So I have interchanged 0 to 1, 1 to 0, 0 to 1, 1 to 0. So this is called a complement or ones complement. Complements are of two types, that is ones complement and twos complement. If you want to get a more detailed explanation, you can check my other video where I have discussed about the complement, how to find out the complement of a binary number. So this is the ones complement. I will change 0 to 1, 1 to 0, 0 to 1, 1 to 0. So there is another type of complement which is called a twos complement. So what is twos complement? Twos complement method means ones complement plus 1. Clear? Two's complement means one's complement plus 1. So we will continue the same example. 1010, the one's complement of 1010 is 0101. Now if you want to find the two's complement of this 1010, so what is two's complement is one's complement plus 1. So what is one's complement? 0101 plus 1. Clear? So it will be 10. So the 2's complement of 1010 is 0110. Clear? 0110. So this is the 2's complement of 1010. So the 2's complement of 1010 is 2's complement of 1010 is 0110. So there is a shortcut to find out the 2's complement. So 1010. Now I want to find out it 2's complement. There is a shortcut. The shortcut is you have to write first, you have to check in this direction and you have to write all the bits as it is until you encounter the first one. Afterward, interchange the bits, or you can say complement the bits. So now I will in the same example I will check. You have to write all the bits as it is until we encounter the first one. So where is the first one? This is my first one, right? So till that part I will write all the number as it is. 0 will be written as it is, 1 will be written as it is. After that you have to complement. So 0 will become 1, 1 will become 0. So this is the shortcut, right? You can see both the answers are same. So let us take another example, 110110. So now I want to find out its two's complement. So what is the traditional method? First you have to find out the ones complement. So what will be its ones complement? Ones complement means 0 will be interchanged to 1, 1 into 0, 1 into 0, 0 into 1, 1 into 0, 1 into 0. To this I will add a 1. So my answer will be 0, 1, 0, 1, 00. So this is the 2's complement of this number. So now I will check whether I am getting the same answer or not using my shortcut. So what is the shortcut? I will check in this direction and I will write the number as it is until I encounter the first one. So here is my first one. So I will write the number as it is, 0 as it is, 1 as it is. After this, just complement. 1 will become 0, 0 will become 1, 1 will become 0, 1 will become 0. Now you can verify both the answers are same. So this is a shortcut by which you can do the complement. So as I said, if you want to learn more about the complements, you can check my other videos. So now coming back to the topic. So the second method in which we can represent a signed number is the complement method. As you know, there is two type of complements, right? One's complement and two's complement. So the the method for representing of signed number is also of two types. One is called the one's complement method. The first one is the one's complement method for representation of a signed numbers. So if the number is positive, if the number is positive, if the number is positive, the magnitude is represented in its true form. The magnitude is represented in its true form, or I can say true binary form. Better I will write true binary form. and a sign bit and a sign bit. I hope you remember what is a sign bit for representing a positive number. It is 0. Sign bit 0 is placed in front of MSB. Clear? So if you observe properly, for the representation of a positive number, the method is almost similar. So if I want to represent a plus 15, so I'll place a 0, 1, 1, 1, 1. That's it. This is the method of representing plus 15. If you observe properly, the method, that is a ones complement method, there is no change for representing of a positive number. Why there is no change means, if you observe in the previous method, that is sign magnitude form, where does the problem came? It came with 100, right? So there are 100 means minus 0, which is practically not possible. So there was a problem with representing of a minus number. So positive number we are fine, we are continuing with the sign magnitude only. So for representing the positive, I am taking a 0, rest all will be represented in a true binary form. Now coming to the second case, that is negative number. If the number is negative, the magnitude is represented in its ones complement form. The magnitude is represented in its ones complement form and a sign bit. So what is a sign bit for representing a negative number is 1, and a sign bit 1 is placed in front of MSB. Let us check. So I want to represent minus 15. Now I want to represent minus 15. So what is the method? If to represent a negative number, the magnitude is represented in its ones complement form. So what is the magnitude of 15 is 1, 1, 1, 1. What will be its ones complement? 0, 0, 0, 0. Right? So now to represent a minus 15, what is the magnitude? Will be 0, 0, 0, 0, and we have to place a sign bit 1 in front of MSB. Clear? So this is my minus 15. Clear? So in this minus 15, this will be sum and this will be my magnitude. Here this will be sign and this will be magnitude. Here this will be sign and this will be magnitude. Now if for example, let us assume that there is a number 1, 0, 1, 0. 1, 0, 1, 0 is a number which is represented in ones complement form. Ones complement method. 1010 is a signed number which is represented in ones complement method. Now with they will ask you what is the number. They will ask you to find out what is the number. So by looking at the magnitude, by looking at the sign bit 1, you can easily understand means that the number is negative. Now we have to find out the value of 010. So what is the common mistake which you guys mostly do in exam is 010 means they will simply write minus 1, right? Minus 1. So that is not the case, but this number what we are looking here 010 is the complemented version of the true number. So next we have to find out its complement. 0 will be 1, this is 1. So what is 1015? So what is this number? The number is minus 5. So that is where many students gets confused. When they see the number 1010, they will think that it is minus 1, but in practically it is minus 5. Why minus 5 means the magnitude in its in this representation has been modified from its true form into complement form. So again to get the number we have to again take its complement. So now the number has become minus 5. So that is how we can represent a signed number using ones complement method. So we have seen how we can represent a complement method using ones complement. So what was the main disadvantage of sign magnitude form? Sign magnitude form was minus 0. We got a combination of minus 0 which is practically not possible. Now we will check whether we are getting such possibilities in ones complement method or not. So let us assume there is for a 3-bit number there is a combination 111. So what does it indicate? By looking at the number you can easily identify that the number is a negative number. Coming to the magnitude 1, 1. So to find out its true value we have to take its ones complement form. So what will be the ones complement? It will be 0, 0. Again, what is the value which we are getting is minus 0. Again, which is practically not possible. Clear? So by now, if you have understood that the first method, that is sign magnitude form, is not used because due to the combination of minus 0. Similarly, coming to the second method, that is complement method. In the complement method, the first one, that is ones complement method, is also not feasible because again we are getting a combination of minus 0. So now we'll look into our last method, that is the two's complement method, right? Next one is the two's complement representation of a signed number. Two's complement representation. Two's complement representation of a signed number. So here also the representation of positive number will be same, that the magnitude will be represented in its true binary form. Magnitude will be represented in its true binary form, and a sign bit. What will be the sign bit over here? Sign bit 0 will be placed in front of MSB. Placed in front of MSB. Clear? So in all the three ways, there is no change in representation of a positive number. Now, coming to the second one, negative number. If the given number is negative, the magnitude will be represented in its two's complement form. Clear? Magnitude will be represented in its two's complement form, and we will place a sign bit 1 in front of MSB. Clear? Now we'll take the same example, representation of plus 15 and representation of minus 15. So how we are going to represent plus 15? It will be 0, 1, 1, 1, 1. This is my magnitude and this one is my sign. Now how we are going to represent minus 15? So we are coming to the magnitude. So magnitude will be represented in its two's complement form, right? Magnitude will be represented in its two's complement form. So we have to find out the two's complement of 1, 1, 1, 1. I hope you know or remember how to find out the two's complement using the shortcut method. What is the shortcut method? You have to check from this direction, write down the bits as it is until you encounter the first one. The first bit is 1 itself. Now we have to interchange the other bits. This is a normal method. You can do it in traditional way also. What is the traditional way? 1, 1, 1, 1. To find out the two's complement, first you have to find out its one's complement. One's complement will be 0, 0, 0, 0 plus 1. One's complement plus 1 is 1, 0, 0, 0. Now you can see both the answers are same. You can do in any way, either by using shortcut or in the traditional method. So we got the two's complement. So minus 15 will be represented by, so what will be the magnitude? 0, 0, 0, 1. And what will be the sign? Minus means 1. So this is how we are going to represent a negative number in its in two's complement method. 1 is the sign, 0, 0, 0, 1 is the magnitude. Now in exam also, sometimes what they will do, they will give you a number like, same example I will take. Now see, there is a number, let us assume a number which is there 1, 1, 0, 1. This is the number which is given in sign magnitude form, which is represented in its two's complement, right? In exam, for short answer, they will give you 1101. What is the value of 1101? In a hurry, what you will do, 1 means you will simply place minus, 101 means minus 5. You will simply write is minus 5. So, but is this correct? Let us check. I want to represent minus 5, right? I want to represent minus 5 in two's complement form. I want to represent minus 5 in two's complement form. What is the first, what is the step? You know, first you have to write down the magnitude in its two's complement form, that is nothing but 101. Next you have to find out its two's complement. What will be the two's complement of 101? 1. I will write down the first bit as it is, then 1, then 0, right? So now what will be minus 5? Minus 5 will be represented by 1, 0, 1, 1. This is how minus 5 is represented. But here in the question they have asked 1101 and you have written the answer minus 5 in a hurry, which is completely wrong. Now to find out what is the real value of this one, what you have to do, First, look at the sign. 1. 1 means minus. You understood that is minus and it has been represented in its 2's complement. To find out the real value of this 101, you have to again take its 2's complement. You have to again take its 2's complement. So, what is the 2's complement of 101? 1, 1, 0. Clear? So, what is the number? It is minus 3. Clear? So, this you have to remember how we are going to represent any number in sign magnitude form or complement form. Now come. Well, now we have to see one possibility. Again, let us assume there is a number 100. 100 is a combination in 2's complement. 100 is a combination in 2's complement. So now we have seen that there are three methods for representation of any signed number. First one is the sign magnitude form. Second one is the complement method. In complement method, there are two types, that is called the ones complement, and the second one is called the two's complement. So out of these three methods, which one is preferred means the two's complement method is always preferred. The two's complement method is always preferred. Why two's complement method is always preferred means in two's complement we don't get a combination of minus 0, whereas in other two methods we got a combination of minus 0, which is practically not at all possible, whereas in two's complement there is no such combination of minus 0. So out of all these methods we'll prefer only two's complement method. So I hope you understood, and thanks a lot. In the next video we will continue with the other topic. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.